Hi everybody, Mr. Rubo here. On today's video, we're going to look at page 20 in your notes packet, and it's going to be about solving equations using logs. So the first thing, I do want you to go ahead and try this warm-up out. It is just a straight matching. Go ahead and do this, and then check your answer with the key, which is on Canvas, and when you are done, then come back to the video. Okay, hopefully you did well. All right, so we're going to go ahead and do a couple examples of some solving of equations. And then we're going to have one last property / formula. And so, yeah. First thing is we're going to look at one of the properties we've talked about a little bit. We didn't use it too much, but we're going to use it a little bit today, which is if m equals n, then log base a of m equals log base a of n. And really, we're actually going to use it more so the other way, where if we know the log base a of m is equal to log base a of n, then we can cancel out the logs and say m equals n. This is what we're going to use more often than not. Yes, we could take the logs of both sides, but it's more so if we have just a log equal to a log, you can with the same base, you can cancel those out. So let's go ahead and keep that in mind, and we're going to go ahead into the first examples here. So here we have log, the common log, so log base 10 of y equals log base 10 of x minus log base 10 of c. And they're telling us we want to express y as a function of x, so we want to basically make it y equals, and the constant c is a positive number. So c is just some number. That's positive. So for this, we want to try to make it so it looks like this, right? We want it to be a log of the same base of something equal the log of that same base of something else. So that way we can cancel out the logs. Well, right now we have one log on the left, two logs on the right, but they're being subtracted. So if you recall, one of our properties is we can rewrite this as division. So we can rewrite it as x over c. And now the logs cancel, and we get y equals x over c. And again, this is just saying express it as y equals, and we've done that. Okay, but the key with this one is you had to get one log on the left and one log on the right. All right, similar idea with number 2 here. We're now dealing with the natural log, but it's no different. It's still a log. So the left side is fine, right? We have one log. The right side, though, we have 3 logs, but they are being added together. So if you recall, that really means we can multiply all 3 things together. And then, again, we can cancel out those logs. And, I mean, if we wanted to, we can multiply this out. So I can do that times that, and then that times that. So that would be cx squared minus cx. Or we could leave it as factored form. It doesn't really matter, right? We could have also just left it. I would have rewritten it as cx times x minus 1. But either answer is fine with the y equals. Okay. All right, so those ones, similar problems. And yeah, you just have to use the log properties until you got it where it was one log on one side, one log on the other. All right, so now this next one, we could solve it a few different ways, but probably the easiest way is doing a little bit of manipulation. And so I guess I should point out here, this one, we have something that doesn't have a log. So again, there's a few different ways of going about this, but the way I'm going to show you is let's get the 2 logs, or how many ever logs we would have. Let's get all the logs to one side. We'll leave this guy alone for right now. So we're going to add natural log of c over 3. And then because I'm adding here, I'm going to kind of do this in the same step. Hey, if I'm adding, that means it's the same as multiplying, right? So y times c over 3 equals negative 3x. Okay, so now comes the what we need to do, because guess what? We want to try to get y. Well, we need to get y out of the natural log. And remember, natural log is base e. So if I rewrite this as an exponential, so it would be e, so remember base e here, to the negative 3x power equals what's inside of the log, which I'm going to go ahead and rewrite it. Actually, no, I'll leave it like this, how I have it. So e to the negative 3x equals y times c over 3. And then again, my whole thing with this is I'm trying to solve for y. So to get rid of c over 3, I'm going to multiply both sides by the reciprocal because it's a fraction. And there we go. This would simplify to y equals, and I can multiply the top. Let me have a little bit more room here. We'll erase part of it. So we're going to have 3e to the negative 3x all over capital C, and there we go. So again, this one was a little different because we had a term without a natural log, or didn't have a natural log or any log, so we couldn't combine it. So we just combined all the logs we could onto one side and then changed it to an exponential. All right, the last thing of this video is one last property. Now, I will tell you this property it used to be more useful than it is now, because if you had an older calculator, this was the only way you could do it. But now with, like I said, most calculators, you can do logs of any base. With slightly older calculators, you could only do logs of base 10 and natural logs. So this is why this was really useful. But again, it's still a good property to know. And so it is called the change of base. So really the change of base formula is this one right here. So it's just saying if you have some log with base A, but you don't want it to be base A, you want it to be some other base, some other number, in this case B, you can change it to that base by doing log base B, B again is the new base, of the same M, divided by log base B of the old base, okay? And again, this is, we can change it to any base we want, so B could be any number. The two that we would use most often, because they are the ones on the calculator, are log base 10 or natural log. Both are technically will give you the exact same answer in the calculator. It was just one way of doing it. But now, since we have log base, change of base is kind of not as useful. But again, if you have an older calculator, this might be helpful. Or honestly, depending on how quick you are with your calculator, it might even be quicker just to type this in. All right. So we can choose whatever base we want to make it into. So I'm going to go ahead and just say log base 10. So my change of base is going to look like this. So it'd be log base 10 of 18 over log base 10 of 5. And there we go. We just changed the base. Now they do want us to go on the calculator and use this. So I'm going to go ahead and bring my calculator over. And here it is. And again, this was because, hey, we have these buttons here, so we don't have to do log base. But again, if you have log base, we didn't need to do this. You know, if I go alpha window, fifth option, and I just type in log base 5 of 18, hit enter, it'll tell me what the answer is, right? Okay, but change of base is really nice because if you have an older calculator that doesn't have this, or if you just forget where log base is, you can do log of 18 divided by log of 5 because it's the log of the thing we're trying to find divided by the log of the old base. Hit enter, and hey, look at that. They are the exact same thing. Crazy. All right, so we end up getting about 1.796. All right. And then again, we do the same thing over here. This one, instead of doing log base 10, I'm going to go ahead and I'm going to choose natural log because it doesn't matter what I choose. I could choose log base 10 of both. I could do log base 20. I could do log base 2. I could do log base 4.5. Okay. Doesn't really matter. Obviously, the two that are the nicest are going to be natural log and log base 10 because we have those buttons. But right there, we've done the convert or the change of base. So now I go to my calculator again, and this one, again, I can do the alpha window, or again, it's under math, and I can put in the 1/2, and then I don't remember what the number was. 15. Okay. I can do that and get this number, which is 100% correct. I can say natural log of 15 divided by natural log of 0.5 or 1/2. And hey, I get the same number. Or again, if you just want to use log, you can totally use log. All of them give us the exact same answer as long as you put in the right numbers. You can see all 3 times we get -3. Negative 3.907. All right. And yeah, that is it for today's notes. So thank you for watching and have a good day.